Oh, hello, my people. Hope we're doing well. This will be the last, second video and the last video on z problems. Let's just go ahead and dive right in. Let's say I have 1 over the square root of z minus the square root of x is equal to 2 over the square root of x plus the square root of y. Now, again, it's a proportion. Again, some of you are thinking, gosh, what I would really like to do is I would really like to cross multiply. And you can, okay? It's not the most efficient way to do it, but if that's what you see and you don't see any other options, go ahead and do so. Now remember, when you're dealing with a proportion, you can actually rearrange the proportion however you want, as long as the cross multiplication, like those cross products, wind up being the same. Okay, so actually you could change it with, square root of z minus the square root of x over the square root of x plus the square root of y is equal to 1 over 2, right? Because at that point you would still get the same products across. But even simpler than that is the fact that, what I do to one side, I have to do to the other when I'm dealing with an equation. Well, can that something be taking the reciprocal of both sides? And the answer is yes. All that really is basically raising both sides to the -1 power. And because the numerator on the left-hand side is 1, when you take the reciprocal, basically what happens is you have a denominator of 1. And then, in order to get z by itself, you simply have to add root x. And then, if you wanted to, you could combine this, right? Because this would wind up, if you multiply it by 2 over 2, winds up being 3 root x plus root y over 2. And that might be a little bit tidier, but you don't have to. And then just square both sides. And you don't have to actually do the squaring. You can just show the squaring, right? Don't make your don't follow what your algebra 1 brain is telling you to do, okay? Just go ahead and just leave it right there. Alrighty. This next one probably a little bit easier compared to the other ones that we have been doing in the last couple, but let's go ahead and do it anyway. Okay. Well, here we have this. Now, here's the thing. I can basically put this over 1 and cross multiply. Eventually, it's going to be the same thing. I need to basically free this z up from this numerator, and that requires that I multiply both sides by 4 minus d. Now, here's the thing. You now have a product here, and your algebra 1 brain is saying that you need to FOIL. In this case, your algebra 1 brain is actually correct, because now that you freed up this z, you have basically imprisoned this z until such time as you actually do the FOILing. So you got your first, and you got your outer, and you got your inner, and you got your last, right? And then I simply need to get all the z terms on the same side, and I get xz plus 4z minus dz is equal to 20 minus 5d minus x. Let's factor out the z, x plus 4 minus d, and 20 minus 5d minus x. And let's go ahead and pull the answer up here. And it winds up being 20 minus 5d minus x over x plus 4 minus d. Now, is there a way that that could have been done in an easier way? I don't know. There may have been a way that may have been able to cut out 1 or 2 steps, but that's just about the easiest way to do it. I mean, there may have been a way to... No, that's pretty much it. Okay, let's go ahead and move on. Have a couple more that, give us a little bit of a different take on the same process. And that's what I'm trying to do. I'm trying to give you a variety of these questions such that we can, we can have facility with isolating z no matter where z is, how many z's we have, and what must be done. In this case, obviously, I have one z. That's really nice. But it is basically imprisoned underneath this radical. So I need to get it out of the radicand by eliminating the radical. Well, I have negative x minus z. If I want to get rid of the 4, I subtract 4 from both sides, right? And so I get 4xy minus 9. Now, you may think that I need to multiply both sides by a negative. Actually, I don't. Because here's the thing. When I square it, the negative's going to go bye-bye anyway. But, if you wanted to, you could, and, make it nice and tidy and whatnot. But if you actually leave it like that, then you don't have 9 minus 4xy. You have 4xy minus 9, which for most people is usually more aesthetically pleasing. So I have x minus z is equal to 4xy minus 9 squared. Now, I can go ahead and flip that difference. I mean, I can either subtract x from both sides and then multiply by a negative, or I can multiply by a negative and then add x to both sides. It really doesn't matter. It amounts to the same thing. And what you wind up getting is that. Okay? So, okay, this one is going to be a little bit different because I think this is the first time I've actually shown you one where the z was imprisoned in the argument of a logarithm. Okay. Well, in order to get it out, I'm going to have to, exponentialize both sides. I'm going to have to undo the natural log by using its inverse. But the first thing I need to do is I need to get the natural log isolated first, okay? So let's go ahead and subtract 1 from both sides, and then I can multiply both sides by -1, and the easiest way to do that is just to flip that difference, right? Now, from here, this is where it can get, kind of fun, I guess. What I need to do is I basically need to raise both sides as the exponent of e, such that then this becomes z minus 1, and this becomes e to the 1 minus x plus y over 3. And you could simplify that exponent. You don't have to. I wouldn't. And that is where you wind up. Now, of course, we could also do an example of where we have the z locked up inside of an exponential and have to take the log of both sides in order to free it up and to be able to isolate it and solve for it. But it would basically just be the reverse of this. Let's do one last one, and I think that will give us a good sampling of all the different ways that z problems can be asked. 2 plus 2 over square root of 1 minus z is equal to x plus y. Now, again, we have a z. You have one z, so I don't have to mess around with recombining it with anything else, but it's under a radical and it's in the denominator. Okay, well, and yeah, that winds up being a little bit pesky, okay? There are a couple different ways that you can deal with that. You could actually transform this expression into a radical and make it, and basically turn the numerator into the square root of 4 so that it's the square root of 4 over 1 minus z. That doesn't seem like it's worth the trouble. What I would do is I would get this fraction by itself, and from here we can do what we did above where we had that proportion and we just took the reciprocal of both sides. And if we do that, we get 1 minus z over 2 is equal to 1 over x plus y minus 2. I can multiply both sides by 2, get square root of 1 minus z is equal to 2 over x plus y minus 2, and then I can square. And the moment that I square, I'm going to get 2 over x plus y minus 2 squared. I can go to z minus 1 and plop a negative out in front of that squared expression on the right-hand side, and then finally get z by itself by adding 1 to both sides. And there you go. Okay, so like I said, there are a variety of ways to do all of these because there's multiple steps and you're using a variety of different operations. As long as you are doing things legally and abiding by order of operations, you'll get to the right answer. It's just a matter of sometimes there is a more efficient way and a way that is less prone to careless errors than others. Okay. If you have any questions, as always, please do shoot me an email. Bye.